Okay, so now the next question asks us, what is the chances between 59 grams, which is here, and 77 grams? So again, we can do the same thing. So we're looking, 59 grams is going to be the mean take one standard deviation to the mean, and I said 59 to 77, so it's going to be to the mean plus 2 standard deviations. So in order to solve this, we just get the sum of probabilities between that. So we'll have the probability of something lying between the mean plus one, take one standard deviation to the mean plus 2 standard deviations. And it's going to be the sum of this. Now, I'll leave it as a percentage at the moment to make it nice and easy to calculate, and then we can convert it to the end. If you do want to actually put it into probability, you can go ahead and do it, but we have 34% plus 34%. Again, this one here and that one there is also going to need to be counted. So therefore we have 68%, because 34 plus 34 is that, plus 13.5%. And you could use arithmetic, or you could use a calculator to be able to work that out, but 68 plus 13.5 results in 81.5. So therefore the probability equals 81.5, where it is where an actual value for weight is between 59 and 77 grams. So probability is, whoops, that's percentage, but as a probability it's going to be 0.185. Again, we just moved the decimal place to suit. Okay, and I did sort of go off the board over there. I guess I didn't know that I was slanting that much. But in case you want the arithmetic there, we have that. That was me just simplifying it down. And I've still gone off the board. Great. Okay. 13.5%. That'll do. Okay, so there we have it. We've actually worked out, okay, what were the probabilities of it falling within a certain region. We know that it's very likely for it to be greater than 53, and it's, you know, quite likely that it's going to be between those two values there. So now, let's say we're actually given a number of eggs, and they wanted us to calculate how many would be suitable for sale. So let's say that this, again, was the actual weights between 59 to 77 grams. And we've got our probability there. So our probability can also be represented as a percentage there for that. So let's say that the number of eggs that were hatched within a week was 1,286. So I like working with percentages where I can, so 1% of that would be 12.86 eggs. Again, it's just 1/100th, so I divide that by 100. And then from that we can tell, okay, if we have 81.5%, it's 81.5 lots of 12.86. So I go to my calculator, and 81.5% times by the value for 1% gives us 1,048 eggs that are suitable for sale. And in context, we just need to double check that that's all good, so we can go 1,286 and we can multiply that by, we can divide that by 2, and we see that obviously it does make sense in context, because if we divide it in half for 60%, we get 643, so that seems a reasonable solution there. Okay, so we've worked out what eggs are suitable for sale based on how many we get on the actual standard deviations there. So one last question we'll look at is maybe, let's see, probably one that's a little bit more difficult. Okay, so the weight of Jason's oranges are normally distributed, and 84% weigh more than 152 grams. Okay, so let's think. 16% of them or 84% of them, sorry, weigh more than 152 grams. So we need to think, okay, where would 84% more than a certain value be? And if we have a look here, 13.5 plus 2.5 equals 16. And 100 take 16 equals 84. So based on this here, just by looking at the percentages in the normal distribution, we can see that our values must be one standard deviation to the left through to the end, pretty much. So it must be greater than the mean, take one standard deviation. So one standard deviation below the mean. Because that gives us 84% of the distribution, and we can tell that off there that this value here is going to be 152 grams, because 84% of it, which is from here onwards, weighed more than that. Now, the next question says 16% weigh more than 200 grams. So again, 16%, well, we just had 100 take 84 equals 16, so it must be the same on the other side at this particular point as well. We must have from anywhere onwards from here, this value here, we must have 16%. Because if we look at it here, whoops. If we look at it here, we have all of those three values there equaling 16%, and 200 grams is where 16% weighed more than that. So we know that obviously if 16% weighed more than that, then we must have 200 grams at the mean plus one standard deviation. So now I need to work out a scale. Now because these are equally proportioned, we're able to go, well okay, what will be the middle number in here? So in order to do this, we have 200 take 152, and that gives us the range, what the range is in between those values. So 100 take 152 gives us 48, and then from that we know that must be 24. So 152 plus 24 gives us 176 in the middle there. And then from there we can fill in the rest, knowing that one standard deviation is 24, so that's 224, that's 248. Back here we have 152 take 24, which is going to give us 128, and then lastly we know that this one must be 104. And so from there we've filled in the distribution. And the question asks us, well, what is the actual mean? And we're able to calculate the mean as being 176 grams, based on the weights of the oranges that we were given before. And we know that the standard deviation is 24 grams, because again, we were able to calculate it, given that 16% were less than the mean, well, one standard deviation below the mean, and we know that obviously there was 16% greater than one standard deviation above the mean. And so from that, we've been able to calculate, using that information, what the actual distribution looks like relative to a scale. Thank you very much for watching the video. Sorry if I'm a bit sick at the moment, but hopefully you are able to still follow along with this video. If you have any questions, please leave them in the comments section below. Thank you very much for watching, and yeah, hope you enjoyed it.